Welcome back. Let's learn how to solve equations of the form ax plus b equals cx plus d. Alright, so far in algebra, we have learned how to solve equations of these three forms right here. Most recently, we learned how to solve equations of this form, ax plus b equals c, and solving equations of this form combined our skills that we learned for solving these two forms, x plus a equals b and ax equals b. But now we're going to take things one step further. Notice that in all of the equations that we have solved so far, that there's only ever been a variable term on one side of the equation. We've never looked at an equation that has a variable term on both sides of the equation. But what do we do if there is a variable term on both sides of the equation? Well, that's what we're going to look at today. We want to solve equations of this form, ax plus b equals cx plus d. There is a variable term on both sides of the equation, as well as a constant term on both sides of the equation. Okay, and specifically we are looking at equations where the variable term on both sides have the same variable part. Alright, and so let's take a look at an example. Here we have an equation that is in that form of ax plus b equals cx plus d. We have 6x plus 11 equals 4x minus 5. Alright, so on both sides of the equation, we have a variable term involving that variable of x. And we also have a constant term on both sides. And so how would we go about solving this equation? Well, you have to keep in mind what our goal is when solving equations. And our goal is to get the equation in the form of a variable equal to a constant, or to isolate the variable, which seems pretty tricky at first because we have two instances of that variable of x. So how do we solve for it, or how do we isolate it? Well, what we're going to end up doing is combining our variable terms. When we solve these equations, we are going to make use of both the addition property and multiplication properties of equations, those properties that we learned in previous lessons. But what we really haven't used so far is the fact that the addition property of equations not only applies to constants, meaning not only can you add or subtract constants from both sides of an equation, but you can also add or subtract variable terms from both sides of an equation. You can do that without changing the solution to the equation. Alright, when we've used the addition property of equations in the past, we've really only done it for constants, but it does also apply to variable terms. And so that's exactly what we're going to do here. Our two variable terms, 6x and 4x, are like terms, right? They have the same variable part of x. So if we were to add or subtract one of those terms from both sides of the equation, we would be able to combine those terms. Let me show you what I mean. To start, I like to draw a divider below the equal sign. That way I can clearly see the two sides of the equation. And I don't forget to do the same operation to both sides of the equation, because remember, whatever you do to one side, you have to do to the other side. That way you don't change the solution to the equation. But what we want to do is pick one of our variable terms and add the opposite of that variable term to both sides of the equation. Alright, so in this case, I'm going to choose 4x. What I will do is add the opposite of that term to both sides of the equation. So since we have positive 4x, what I'm going to do is add negative 4x to both sides. Or you can think of it as subtracting 4x from both sides. If we do that here, if we subtract 4x from both sides, and I would write it below your other variable term, just like I've done right here, watch what happens when we simplify. On this side of the equation, 4x minus 4x would be 0, right? These would be two like terms with the same variable part of x, so you could combine them by adding their coefficients, and 4 plus negative 4 is 0. So you would get 0x, which is just 0. So you have 0 minus 5 on this side of the equation, but then over here, 6x minus 4x, those are also two like terms, so you can combine their coefficients, and 6 plus negative 4, or 6 minus 4, is 2. So we get 2x and then plus 11. Alright, and so now notice what we're left with. We no longer have an equation with a variable term on both sides of the equation. We just have one variable term on one side of the equation. Alright, we are left with 2x plus 11 equals negative 5. And so now, this should look like an equation you already know how to solve. This is what we looked at in the previous lesson. We have a constant times a variable plus a constant equal to another constant. And so what we'll do here is work towards our goal of isolating that variable of x by getting rid of this constant. So we're going to add the opposite of that constant to both sides of the equation. In other words, we're going to subtract 11 from both sides. So let's do that here. If we subtract 11, 11 minus 11 is 0. So we're just left with 2x plus 0. And then negative 5 minus 11 is negative 16. And so really we just have 2x equals negative 16. And so then we could finally isolate x by dividing both sides of the equation by 2. Okay, so if I do that here, dividing both sides by 2, we'll just leave you with 1 times x, because 2 divided by 2 is 1. So that would just be x. And we'll have x is equal to negative 16 divided by 2, which is negative 8. Okay, so that is the solution that we found for this equation. Now let's check that. Let's see if that really is the solution to this equation. If we plug that value of x that we found back into the original equation, here's what we'll get. We'll have 6 times x, which we're saying is negative 8. So we have 6 times negative 8 plus 11 is equal to 4 times x, which once again, we're saying is negative 8. So we have 4 times negative 8 and then minus 5. Let's see if we get the same value on both sides of the equation here. 6 times negative 8 is negative 48. So we have negative 48 plus 11 is equal to 4 times negative 8, which is negative 32. And then we have minus 5. Negative 48 plus 11 would give you negative 37. And you get the same thing over here. Negative 32 minus 5 is negative 37. And so that checks out. Negative 8 is the solution to this equation. Okay, and so our method here works. When you have equations of this form, where you have a variable term on both sides of the equation, where those variable terms are like terms, what you want to do to start is combine those like terms. All right, you want to add the opposite of one of those variable terms to both sides of the equation to eliminate the variable term from one side, and so you only have one variable term on one side of the equation. Okay, now something that you might be wondering is, why did I choose 4x, right? Why did I subtract 4x from both sides of the equation rather than 6x? And really, it doesn't matter. I could have also subtracted 6x from both sides of the equation and then continued with our methods of solving equations, and we would still get the same answer of negative 8. And so let me show you that here. We're still starting with the same equation, 6x plus 11 equals 4x minus 5, but let's say that instead of starting by subtracting 4x from both sides of the equation, we subtract 6x. All right, so we're going to subtract 6x from both sides. So on this side of the equation, 6x minus 6x will be 0. You'll get 0 plus 11. And then over here, 4x minus 6x, they are like terms, so combine the coefficients. 4 plus negative 6, or 4 minus 6, is negative 2. So you get negative 2x minus 5. Then we want to isolate the variable term, so add 5 to both sides of the equation, since positive 5 would be the opposite of negative 5. So we'll add 5 to both sides, giving us 16 on this side, and then negative 2x plus 0 on this side. All right, but really, we don't care about that 0. What we would then do to isolate x and solve for it is divide both sides of the equation by the coefficient of that variable, which is negative 2. So if we divide both sides by negative 2, we get the same answer, because 16 divided by negative 2 is negative 8. Negative 8 will be equal to negative 2x divided by negative 2. Negative 2 divided by itself is 1, so you just get x. And so negative 8, once again, is a solution that we find for this equation. It doesn't matter that we have negative 8 equals x as opposed to x equals negative 8. That's the same answer. It means the same thing. And so clearly, there are multiple ways to go about solving these equations. There's not just one single way to go about things here. As long as you do the math correctly, you will get the same answer no matter which variable term you choose to remove from one side of the equation. Okay, now with that being said, generally what I will do is try to remove the variable term on the right side. That way when the equation is solved, you have the variable on the left side of the equation. It just looks nicer as x equals negative 8 compared to negative 8 equals x, but ultimately it does not matter. Okay, so I hope that's clear. you have some options when solving these equations. And so now that you've seen how to solve equations of this form, let's look at a couple more examples for practice to close out this lesson. Alright, so for our next example, we want to solve the equation and check the solution. This time our equation is 8y minus 7 equals 4y minus 3. Okay, so clearly this equation has two variable terms, one on each side of the equation, 8y and 4y. So what we want to do to solve for y in this equation is first combine those like terms. Alright, we want to have one variable term on one side of the equation. And so we want to choose one of them to remove. I'm going to choose 4y. So what I want to do is add the opposite of that term to both sides of the equation. Or in other words, we're going to subtract 4y from both sides. So let's do that here. We'll subtract 4y from both sides of the equation. And so then simplifying, on this side we'll just have 0 minus 3 because these are like terms with the same variable part. So adding the coefficients, 4 and negative 4 gives you 0. So you have 0 minus 3. And then over here, once again, we have like terms. They have the same variable part of y, so combine the coefficients. 8 minus 4 is 4. So we get 4y minus 7. So we have 4y minus 7 equals negative 3. And so the next thing we want to do here is isolate the variable term. So we want to get rid of this constant on this side of the equation. We can do that by adding 7 to both sides, right? Adding the opposite of that constant. So if we add 7 to both sides of the equation, negative 7 plus 7 is 0, just leaving you with 4y on this side of the equation. But then over here, negative 3 plus 7 is positive 4. So we have 4y equals 4, and so to finally solve for y, what we can do is divide both sides by the coefficient of that variable term, which is 4. So if we divide both sides of the equation by 4, we will get that y is equal to 1. Right? 4 divided by 4 is 1, 1 times y is y, and then 4 divided by 4 is 1. So we find y equals 1 as the solution to this equation, but let's check it. Let's make sure that it really is the solution to this equation. So if we check our work, we're going to plug in 1 for each of these y's. We'll have 8 times 1 minus 7 is equal to 4 times 1 minus 3. And so if we simplify, 8 times 1 is 8, and 4 times 1 is 4, so we get 8 minus 7 equals 4 minus 3. All right, and then 8 minus 7 is 1, and 4 minus 3 is 1, so we get 1 equals 1, which is a true statement, and so y equals 1 is the solution to this equation. Let's take a look at another example. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Next up, we want to solve this equation and check the solution. Our equation is 1/3 x plus 1/2 equals 1/4 x minus 1/3. And so this is kind of a nasty equation because there's fractions everywhere, right? There is a fraction in every single term in this equation. And so you could try to solve this in the same way that we have solved the previous two equations, but I think there's something that we can do here first that will make solving this equation a lot easier, okay? Because dealing with fractions is not always nice. You have to get common denominators in order to combine like terms. And so if you were to add the opposite of either 1/3 x or 1/4 x to both sides of the equation, that would make for some messy work. And so what I think we should do instead is try to remove those fractions, or in other words, get rid of those denominators in the terms of this equation. We did something very similar in the previous lesson when we learned to solve another type of an equation. Remember that for an equation, you can add, subtract, multiply, or divide both sides of an equation by pretty much any number as long as you do that operation to both sides of the equation. all right? That way you don't change the solution. So what we can do here is multiply both sides of this equation by some number that is divisible by 3, 2, and 4, our three different denominators. That way all of the coefficients and constants in this equation are whole numbers as opposed to being fractions. All right, so we have to think of a number that can be divided evenly by 3, 2, and 4. And so you could try to think of the LCM or the least common multiple for those three numbers, or really any multiple of all three of them, but the least common multiple would be the easiest to work with. In this case, it would be 12. All right, 12 can be divided by 3, it can be divided by 2, and it can be divided by 4. If you're ever not sure what a multiple is for all the numbers, just multiply them all together. 2 times 4 is 8, times 3 is 24. So 24 would work as well, but 12 is just a smaller number that can be divided by all three of them. Okay, so the LCM for 2, 3, and 4 is 12. So that's what I'm going to use here. But once again, you can use any multiple shared by these three numbers, and you can multiply that by both sides of the equation, and you would still get the correct solution when solving for the variable. Okay, but if we multiply both sides by 12, here's what we'll get. We'll have 12 times 1/3 x plus 1/2, and that will be equal to 12 times 1/4 x minus 1/3. All right, and if you want, it can be helpful to draw that divider so you can clearly see the two sides of the equation. Be sure to multiply 12 by both sides and by all of the terms on both sides. All right, don't just multiply 12 by the variable term and forget to multiply it by the constant. Same thing over here. You need to multiply 12 by everything on both sides of the equation. And so now using the distributive property, we're going to multiply 12 by both of the terms in this quantity, and we'll do the same thing over here. 12 times 1/3 x, that will give you 12 divided by 3 times x, but 12 divided by 3 is 4, so we get 4x plus 12 times 1/2. You can multiply 12 into the numerator and get 12 divided by 2, which is 6. So we have 4x plus 6 on this side, and then over here, 12 times 1/4 x would give you 12 divided by 4x, but 12 divided by 4 is 3, so what we get here is 3x, and then 12 times negative 1/3, that will give you minus 12 divided by 3, but 12 divided by 3 is 4, so we have minus 4. Okay, and so now we have a much easier equation to work with. No longer do we have 4 different fractions that we have to worry about. We now have all whole numbers, which are going to be much easier to work with. And so now, let's actually try to solve for x. We still have a variable term on both sides of the equation, so we want to remove one of them from one side of the equation. I'm going to choose 3x. Let's get rid of this one. So what we want to do is add the opposite of that term to both sides of the equation, or in other words, we're going to subtract 3x. So let's do that here. I'm going to subtract 3x from both sides of the equation. On this side, 3x minus 3x is 0. That's the whole reason we subtracted 3x. So we get 0 minus 4. And then on this side, 4x minus 3x, they are like terms, so combine the coefficients. 4 minus 3 is 1, so you just get 1 times x, which we would just write as x. Okay, so we get x, and we still have that plus 6, which is really nice because now there is no coefficient really for x, it's just 1. So the only thing we have to do to solve for x here is remove this constant from this side of the equation. What we want to do is add the opposite of 6 to both sides, or in other words, subtract 6 from both sides of the equation, and we'll be done. All right, so if we subtract 6 from both sides, I'll write the final answer over here. We're going to have x plus 0, because 6 minus 6 is 0, so we get x is equal to negative 4 minus 6, which is negative 10. And so x equals negative 10 is the solution to this equation. Now let's check it. Let's plug this value of x back into the original equation and see if we get a true statement. I suppose you could plug it into this equation down here. 4x plus 6 equals 3x minus 4. That would be easier. But just in case you made a mistake in this step when you multiplied both sides by the LCM of the denominators, I think it's going to be a better idea to check your answer in the original equation. Okay? That way you can catch any of your mistakes in your work that led up to your answer. So let's plug our answer in. We're going to check our work now. We'll have 1/3 times negative 10 plus 1/2 equals 1/4 times a negative 10 minus 1/3. Unfortunately, it does look like we're going to need to get some common denominators in order to add our fractions and check our work. But first, let's just multiply negative 10 into the numerator of 1/3 and 1/4. We'll have negative 10 divided by 3 plus 1/2 equals negative 10 divided by 4 minus 1/3. Now, to get a common denominator in each case so that you can combine these two sets of fractions, just multiply each fraction by a form of 1 using the other fraction's denominator. All right, so negative 10 divided by 3 will multiply by 2 divided by 2. All right, so we have 2 divided by 2 multiplied by that. And then for 1/2, we'll multiply it by 3 divided by 3. All right, I'm just going to squeeze that in there. Same thing over here. We'll multiply negative 10 divided by 4 by 3 divided by 3. And we'll multiply negative 1/3 by 4 divided by 4. We're just multiplying by a form of 1 using the other fraction's denominator. Okay, now I know this looks a little bit messy, so let's clean it up. Multiplying all these fractions, 2 times negative 10 is negative 20. So we get negative 20 divided by 6 plus 3 divided by 6. 3 times 1 is 3, 3 times 2 is 6. And that will be equal to negative 30 divided by 12 minus 4 divided by 12. Okay, 3 times negative 10 is negative 30, 3 times 4 is 12, 1 times 4 is 4, 3 times 4 is 12. And so now we have common denominators, so we can combine the numerators. Negative 20 and 3 become negative 17, and negative 30 and minus 4 become negative 34. So we get negative 17/6 is equal to negative 34 twelfths, which doesn't look true at first, but negative 34 divided by 12 can be reduced. That is not a fraction that has been fully reduced. Both 34 and 12 are divisible by 2. So what we get here is negative 17/6 is equal to negative 34 divided by 2, which is negative 17, and then 12 divided by 2 is 6. So we do get an equation that has the same value on both sides, which means that our solution of x equals negative 10 is true. That is in fact the solution to this equation. Okay, and so that's it for this example. Let's take a look at one more for this video. All right, so here's our last example. We once again want to solve the equation and check the solution. This time our equation is 2/3 b equals 2 minus 5/6 b. All right, so in this case, our equation still has two variable terms, one on each side of the equation, but one side of the equation doesn't have an extra constant term. You could think of that constant term as just being 0. So that will make our solving process a little bit easier, but we still have to combine our variable terms, or in other words, remove one from one side of the equation. But before we do anything, once again, we do have fractions, and so I would like to get rid of those if at all possible. You want to think of a common multiple of the two denominators, that being 3 and 6 in this case. And that's a pretty easy one. We know that both 3 and 6 divide into 6, right? 6 divided by 6 is 1, 6 divided by 3 is 2. So that would be our LCM here, our least common multiple. So I'll start by multiplying both sides of the equation by 6. And that will get rid of our fractions, or those denominators, which will make solving the equation for b, our variable in this case, a lot easier. All right, so 6 times 2 is 12. 12 divided by 3 is 4. So we get 4b on that side of the equation. And then on this side, 6 times 2 is 12. So we have 12, and then minus 5 times 6, which is 30, divided by 6, which is 5, right? You'd get 36 times b, but 30 divided by 6 is just 5, so we get 5b. Okay, so now we have an equation that is much easier to work with. Multiplying both sides by 6 does not change the solution, it just changes how our equation looks, and now it looks a lot easier to solve. Okay, so now what I want to do is remove one of our variable terms from one side of the equation. In this case, I think I'll get rid of this negative 5b by adding the opposite of that term. So what I'm going to do is add 5b to both sides of the equation. So we'll have plus 5b on both sides. Over here, we're just going to be left with 12 because negative 5b plus 5b is 0. So we just have 12 on this side, 12 plus 0 technically. And then over here, we have like terms, and so 4 plus 5 is 9, giving us 9b. So we have 9b equals 12, and so to solve for b, we need to divide both sides by 9, the coefficient of the variable term. And so if we do that, divide both sides by 9, 9 divided by itself is 1, so you're just left with b. So we get b is equal to 12 divided by 9, but that is a fraction that can be reduced. Both 12 and 9 are divisible by 3. 12 divided by 3 is 4, 9 divided by 3 is 3, so we get 4/3. All right, so b equals 4/3 is the solution that we found here, but let's check it. Let's plug it back into our original equation and see what we get. Let's see if we get a true statement confirming that our solution is correct. We'll have 2/3 times b, and then that will be equal to 2 minus 5/6 b, where b is 4/3. All right, so 2/3 times 4/3 is equal to 2 minus 5/6 times 4/3. All right, now 2 times 4 is 8, 3 times 3 is 9, so we get 8/9 is equal to 2 minus 5 times 4 is 20, 6 times 3 is 18, so we have 20 divided by 18, and then 20 divided by 18 can be reduced. Both 20 and 18 are divisible by 2, so what we get is 8/9 is equal to 2 minus 10 divided by 9, right? 20 divided by 2 is 10, 18 divided by 2 is 9. And then to simplify this, we need to express 2 in terms of ninths, which would be 18 divided by 9, right? 18 divided by 9 is 2. So I'm just going to rewrite that here. 2 would be the same as 18 divided by 9. And so now we have a common denominator. 18 minus 10 is 8. So we get 8/9 is equal to 8/9. Both sides of the equation are the same number, and so our solution is correct. b equals 4/3 is the solution to this equation. Okay, and so that is it for this example, and this was also the last example for this lesson, but if you do want to get some more practice solving these types of equations, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.